Hello everyone, welcome to another art tutorial video. In this video, we're gonna learn about linear models. So after watching this video, you will learn how to search new functions, and we're gonna learn about the particular function named LM, which is used to build the linear models. And second, we're gonna fit the linear model and then plot the linear model together. So let's start. Okay. So when you know that there exists something in our environment, but do not really know how to use it, what it is, you can use this question mark. So I know there exists something called LM in our environment, but I don't know how to use that. So I'm gonna search it and look up this function called LM here. It says fitting linear models, and it says LM is used to fit linear models. So I think LM is a function that helps me to build a linear model, but then I do not actually know what linear model is. And that is what I'm going to tell you. Before we jump into what linear model is, I want to explain more about the concept of class and objects. So imagine that I have a banana in my hands. This banana is a fruit, and I have a fruit in my hands. When I say it's a fruit, I am referring to its class. It's the type of this banana. So this is not a I don't know. This is not a stationery. This is not some type of pens or some kitchen utensils. It's just it is a type fruit. And so the concept of this type, class, fruit matches together, and then the banana as a realization of an object that has a type fruit is an instance. So going back to the computer science concept, we call something the structure or type of something as a class, and then when we make something that has this particular class, we call it an object or an instance. So when I am going to fit this linear model in this R environment and then save it into an instance named fit, but then this fit corresponds to the banana, and then this linear model corresponds to the fruit in the daily exercise. And so this linear model is what we're going to create using this LM function, and then this is the uses of the LM function. But then what's important here is the formula, and then the rest of it is also useful. But then I am not going to go over every detail of this. But if you are interested, you can look it up using the same question mark LM command here, or you can just Google it, and then there will be tons of explanations. But in this video, we're going to only cover the essentials. So now we have an understanding of what linear model is, and we're going to fit the model together. So let's go. To create the linear model, we need some data points, right? So here I'm gonna create some artificial data that I just arbitrarily chose some numbers and saved it. So here, as a recap of what we talked like 3 minutes ago, this is a column vector, and then I saved it into an instance named height. So height is something that's similar to our bananas, and this is data that has a vector type. So this is a vector class. This height is an instance that has a vector class. Also, this body mass is a instance that has a vector class with, I guess it's 10 inputs. So here we have two vectors containing 10 numbers. What we're gonna do is we're gonna fit this height into the body mass. And the order of fitting A to B or B to A matters because of the construction of linear model. And then here I will show you some grammars of using LM. So this command means that we're gonna run this linear model LM function, and we're gonna learn what this means exactly soon, but let's ignore it for now. And we're gonna run this LM function with this input, and then we're gonna save it into fit. So this fit is an instance that has a linear model class. And so let's look into this. So this body mass is what I created here, and this height is what I created here. And we match these two using this squiggly line. This is not a minus sign. And this is the formula. This is just how people agreed in the R community to express a formula. That means we're gonna fit this height to body mass, meaning that height is what we usually have in the x-axis, and then body mass is what we usually have in the y-axis. So keep that in mind, and we're gonna run this fit. Now we have this fit here, and it is pretty complex. But good thing is that no error, that we successfully constructed a linear model and saved it into fit. Now let's use the basic functions that we learned and check if the fit is correctly constructed. First, we're gonna check if the class of the fit is actually linear model, and it outputs LM, meaning that it is linear model. Let's see how this linear model is constructed using the summary function. Here, it has a lot of information, but what we can interpret as of now is that it has a call. It's the formula that we use to fit the linear model. And I guess it also has some, it also contains some numbers that represent the residuals after we fit the model. And I also think there's a coefficient. The intercept will be the intercept in the y-axis, and the height, and this one, this number here is the coefficient named height, and that's the slope of our linear model, like linear fit. And by the way, this is the intercept. And blah 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 blah, but the most important thing is that we had this formula, and then we obtained the important coefficients that we're going to use here. Additionally, we can also check the names of fit. So this function names calls the name of the columns of this data frame. And it has coefficients, residuals, effects, rank, and blah, 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 blah. So some of you might understand everything. Some of you might not understand what a sign is. Personally, I do not know everything here, but the useful thing is that we can just Google R linear model X levels, and then we can find out tons of information explaining what it is, and then now you have the ability to search something that you want to know. Now that we have the linear model fit, we're gonna plot the linear model together. There are many ways to plot the linear model, but this video will teach you the most basic thing that you can do right after you construct your linear model. Plot function is just a plot function, and here you can input the x and y of your data points, and then it will just plot x comma y values in your graph, meaning that you will have your first input of height, comma your first input of body mass, as so that represents a dot in 2D space, and that will be marked in your graph. It's better to just see than explaining the graph in words. Here it is. So x-axis is height and y-axis is body mass, and then we have 10 data points. Remember that we use this formula. The formula that we used in the linear model is body mass, squiggly line, and height. And as I expressed earlier, this is y squiggly line x. But here, the plot function is the other way around. The x-axis values comes first, and then the y-axis value. Now that we have the original data points, we're gonna draw a line that we obtained using the LM function. AB line is a function that helps you to draw a straight line on your 2D graph. And what's convenient here is that you can directly use your linear model fit into this AB line function. And then this means that I chose a color red to draw this just because I wanted to. You can just put green or blue here. Ta-da! Now we have a nicely fitted linear regression line on our plot. This is the line that was created using the coefficients that we obtained in this obtained using the LM function, and then saved to fit. Going back to the coefficients, so this line will have some have the intercept with the y-axis somewhere here-ish, because this is already 130. 0 will be somewhere like here, right? And then this line will go downward over there, and then hit the y-axis at the y-axis at x is equal to 0 point at where? Here. Y is equal to negative 17. And this means that the slope, when we set the height as an x-axis, the slope will be 0.8528, which is this line, which is slightly like it's similar to 1, but then it's slightly slope downwards here. Not sure. Yes, because I think x-axis and y-axis are somewhat evenly spaced, because this length here is 10 in y-axis and this length here is 10 in x-axis, so I think it's almost even. So yes, So this line corresponds to the numbers that we got here. So this is the basic of the linear model, and I hope this was helpful to start with your journey with this amazing function LM. And this is just the basic and essential parts of the linear model, but there are a lot of things that you can do using this new class. So we will provide you with 2 useful links behind this below this videos, and please do research more about this linear model function. Good luck with your homework and everything. Thank you.